Alright, this is example 4 of improper integrals. This one's not pretty. This one will be one of the longer videos. Alright, so first I start with a rewrite. Remember, with these problems, you have to rewrite the problem as a limit. So it's going from 1 to b instead of 1 to infinity, and let the b going to infinity. And you might be thinking, well, what's the difference? Well, I don't know, it's a rule. Alright. Alright. Oh, what do I do? Okay, so this is one of those problems. Okay. So I'm going to let u equal 1 minus x and dv equal e to the negative x dx. And you might be wondering, well, how did I know that I had to use integration by parts? Well, if the derivative of the numerator is not out here, and there's more than enough, like this is an algebraic expression with e to the x, that's going to be an integration by parts problem. Right? So if you have some kind of algebraic expression, right, and the degree of this out here is either bigger or equal to the degree of the exponent, you're going to have to do integration by parts. Right? This exponent has a degree of 1. This binomial has a degree of 1, so I have to do integration by parts. All right. So du equals negative dx, and v equals negative e to the negative x. All right, so I took the derivative here, I integrated here. All right, now I'm doing uv minus v du. So uv, so that's going to be 1 minus v negative e to the negative x minus, so it's a minus a minus. Oh, there's a bunch of minuses, so that's 3 minuses, so it stays a minus. E to the negative x dx, and it's going from 1 to b, and this is going from 1 to b. Okay. So that part is going from 1 to b. Okay, sorry. Thankfully, we don't have to do it once. So I'm going to go ahead and distribute that negative, so that makes it v minus 1, e to the negative x, not vx, sorry. Alright, and then minus a minus, so it's plus e to the negative x, and all of this is taken from 1 to b. Alright, now let's go ahead and plug it in. So it's going to be b minus 1, e to the negative b, plus e to the negative b, minus, plug in the 1. So 1 minus 1 is just, so wipes that out. So I just have the e to the negative 1, or just 1 over e. Right? So when I plug in 1 into this expression, that's 0. So that wipes out this term. When I plug a 1 in there, it's e to the negative 1, so it's just 1 over e. Okay, so this part is the only part that has the b in it. As b goes to infinity, so what is this doing? So let's do this. Let's go ahead and take out e to the negative b out. So if I take e to the negative b out, that leaves me b minus 1 plus 1. So that part cancels. So e to the negative b times b. Okay, I don't know why I use parentheses. All right. So negative 1 plus 1 cancels, leaving me just b. So continuing. So that's b over e to the b. Alright, so what I have is infinity over infinity. Okay, I'm going to ignore the minus 1 over e. Right, you can think of it as this, that you've taken the limit of that, so it's just this minus 1 over e. Okay, it's not the limit of that. The limit of that minus 1 over e. Okay, so here, if I do this, limit as b goes to infinity, is infinity, and limit as b goes to infinity of e to the b is also infinity. That's a really ugly infinity sign. I can't get any better. Alright, so that's an infinity. Believe it or not, that's an infinity sign. There we go, that's better. Right. So I have infinity over infinity, which means I can use L'Hopital's rule. When I use L'Hopital's rule, I have limit as b goes to infinity of 1 over e to the b, and this is a minus 1 over e. Okay. Alright, as b goes to infinity, this is going to 0. So that means the final answer is negative 1 over e, which is kind of disturbing. Okay. Alright, that's it.